Hello friends, welcome to engineering tutorial. So today we are going to resume our discussion on the subject of television engineering, and so far I think I have posted 5 or 6 videos related to this subject, the basic introductory concepts, and the last few videos were related to color characteristics, where we discussed the various characteristic features of colors which are related to television engineering, and also related to, you will find the same things in image processing, but more towards television engineering. So we'll take our discussion forward. So in this video we are going to discuss about some more color characteristics, particularly focused on three important features, which is hue, saturation, and luminance. We'll discuss about these three things. Okay, so we have discussed about various aspects of the image related to colors for basically the color television, whole that thing, such as brightness, tonal gradation, various characteristic features of image, pixels, brightness of pixels, everything. So another important feature associated with colored light, which has the basic three components of colored light, they are hue, saturation, and luminance, and together they are called as HSL, abbreviated as HSL. And each of these characteristic features, it can give extra dimension, separate, add something extra to a color, the color of an object. And each of them can manipulate it in different ways, and each of them controls different aspect of the color. Okay, so hue, saturation, and luminance. So first is hue. So basically what hue means is it is the dominant spectral color in the light which is coming from an object after it is reflected from the object. Okay, so by dominant spectral color I mean it is the wavelength of light which reaches the human eyes after getting reflected from the particular object. Okay, so the dominant wavelength which reaches the human eye, that is called as hue. Okay, now it is also called as tint. Okay, so basically what hue means is it is the color of the object that we see, the actual color. Like we say roses are red, leaves are green, sky is blue, like that. Now an important characteristic feature related to hue is that here you cannot say that the particular rose we see, they are available in different shades of red. Okay, different shades. Some can be light red, some can be deep red, something can be a little bit orangish, something can be a little bit pinkish. Like I'm saying, different colors of red that we see. Now the eye, it cannot distinguish between closely spaced shades of a particular color. Similarly, the leaves that we see, they are available in different shades of green. Some can be light green, some can be deep, like that, but it is green. Leaves are green, it can be light, it can be deep, it can be in any shade, but it is green. Similarly, roses are red, it will stay red, it can come in light red, it can come in deep red, like that, but it will stay red. Similarly, we say sky is blue, so that red, that blue, that green color of leaves, red color of rose, that is called as the hue. It is the dominating color, the dominating wavelength that reaches the human eye. As the human eye cannot, uh, it cannot make out separately the closely spaced shades of color, separated by narrow or small fraction of wavelengths. So for example, as I said, the rose can be of any shade of red. From here, let's say it is deep red, and as we move from left to right, it becomes little bit light in color. Each shade is a little bit light from the previous shade. So like that. So similarly, we can say for leaves, as we move from left to right, it will start to fade in its color, becoming more and more light. So that's I'm trying to say, that all of these things, they are red, but it can start from deep red and then gradually become more and more light. And here you can say it is more towards pinkish, the pinkish color, but some can say it is light red. They will not be wrong. So like that. Similarly, another important aspect is saturation. Again, saturation basically means how much white is present in a color. Okay, how much white is present in a color. And presence of white basically turns the color pale. It fades, makes it more and more light, as I said. So the absence of white in a color makes it fully saturated or vivid, deep color. And unsaturated color means presence of white. It produces paleness in the color. The color fades. As we say that color is fading in our different garments or our shirts or anything. We say that the color is fading. It means it is becoming more and more pale. It can be because of various reasons. So that is what saturation is all about. The presence of white in a color in different amounts, in different concentrations, which produces paleness in the color. Okay. Now here, the same thing we can explain it in a different way. For example, vivid red, that is red color with no white presence, or that is 100% saturation, the same color, it may appear pink with 50% saturation, that is 50% presence of white. The same thing which I was discussing while discussing hue. That see, this left side, extreme left, that is vivid red, no presence of white at all. But as we move towards the right, the concentration of white in the color keeps on increasing, and which dilutes the color, fades the color, and when it increases to, let's say, 50% saturation, the same vivid red with 50% saturation, it appears as pink. Okay, so all of these is they are all, as I said, manipulated by these three characteristic features: hue, saturation, luminance. When we change these three features, we can play with colors. Okay, we can make red look like pink, we can make green look like yellow, so like that. So all of these is related to that. Next is luminance. Okay, so luminance is another important characteristic feature, which is basically related to the picture elements in an image. I've already discussed about pixels or picture elements. So luminance is basically the brightness of a pixel, the brightness of the color of light which is emitted from one particular pixel. For example, let's say we have an image and we convert it into horizontal and vertical pixels, and the amount of light which is coming out from one single pixel, that is called as luminance. Okay, it does not take into account the surroundings, the overall brightness. It is only the brightness coming from a certain pixel. Let's say all of these, the whole thing is separated or divided into horizontal and vertical pixels. So here the amount of light coming from each of these pixels, it is different. So the luminance of each of these pixels is different. Okay, so it is only associated with that one particular picture element, not with the whole, the overall thing. Only one pixel. Luminance is associated with one picture element or pixel, the brightness of that one pixel. So another important thing which we can understand, we have discussed about the primary colors red, green and blue, and how different colors, the secondary colors or complementary colors, are formed by red, green and blue. I've already discussed. So another important concept which brings together all these things which we have discussed is the Grassmans Law. So it basically says that when a color, complementary color or secondary color, is made by adding the three primary colors red, green and blue, we can determine its luminance by Grassmans law. So the luminance of a secondary color or complementary color is given by 0.59 the luminance of the green color, 0.3 the luminance of red and 0.11 the luminance of blue, where the unit of each is in lumen. So here Y is luminance of the secondary or complementary color, and GR and B are the intensities of green, red and blue, the primary colors in lumen. So this is the Grassmans law. Okay, so we have discussed about hue, saturation and luminance. So let us try to understand it from in a practical way. Now if you have used any photo editing application, paint application, drawing application, where colors, selection of colors is involved, then when you select a particular color, okay, you will have three parameters involved, as you can see here. Okay, so here each of these three parameters, they are for a particular combination of the three primary colors red, green and blue. Okay, so here as you can see it is black, for which it is given here the hue is 160, saturation is 0, luminance is 0. Let's say we pick red. Okay, so here hue is 0, saturation is 240, luminance is coming 120, and here in this green 0, blue 0, red is 255. Then let us pick let's say blue. For this blue color, hue is 160, saturation is 240, luminance is 120. Here blue is coming 255, green is 0, red is 0. Similarly green hue is 80, saturation is 240, luminance is 60. Here green is coming 128. Now if we pick, let's say, different shades of red by adjusting this, okay, when we change different shades of red from dark and then to white, here you can see the hue value is staying at 0, but the luminance value, it is changing. Okay, here, and also the different values of red, green and blue, they are getting changed. Similarly, when we pick blue, let's say, and we change its different shades, okay, as we increase and decrease, the luminance value is changing, the saturation and hue value is fixed at 160 and 240 for this particular shade. Similarly, when we do it for green, let's say, when we change different values, the hue value is 80, the saturation value is 240, and the luminance value, which basically is the brightness level, it is continuously changing, and when it is 0 it is almost black, and when it is maximum it is white. So luminance, brightness level, it changes the as you can see, the brightness, the paleness of the color, okay, from dark to white, black to white. Similarly, for each particular color, you can see there are different values of hue, saturation and luminance. Okay, see, any color you pick, they will have particular combination of hue, saturation and luminance. Okay, so this is particularly important when we are discussing about the primary colors, the secondary colors, about the the color triangle, the chromaticity diagram. So all these things will come into play. Okay, see, a particular color we pick, it will have a particular combination of hue, saturation and luminance, and also the various quantities of red, green and blue. Okay, see, the red, green and blue, which is the primary colors. Always remember, red, green and blue, they are the primary colors, and it is because of these combination, different amounts of red, green and blue gives us all the other colors. Okay, so this is blue, all the other elements are 0, blue is the dominant color. When we pick red, red is the dominant color, green, blue all is 0. Similarly, in green, red is 0, blue is 0, green is 128. Similarly, when it is white, equal amounts, red, green and blue in equal amounts, it gives us white. Black, everything is 0, it is giving us black. Okay, so hue, saturation, luminance values and red, green and blue primary colors, they are of prime importance when it comes to the different types of colors that are formed. Okay, so here we have discussed about hue, saturation and luminance. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.